Hello, I will now demonstrate to you how to read and edit a mesh generated with Polymesh using our TWIST IDL tool. So you will find information about installing IDL and the TWIST tool on our wiki server. So here is the address. One way to get there is to start from the Iowaga webpage. So just Google on Iowaga and you get there. And just follow the links to the products page, and then the first thing here is the wiki. And once you're on the wiki, you can then search for the IDL tool and you get to that page. Alright, so I have actually just opened the tool, just looks blank now. And so what I will do now is to read in a mesh file, and you will find the details for reading that mesh file on this wiki page here. And the case I will use is an example for Hawaii. So just go down to the summary here, and we'll just follow this link here, which I will fill in a few minutes. Okay, so we're going to read Gmesh triangle-based grid. So we just open the file drop list, click on this, and we'll look for it. And I have it in my tools, Polymesh test cases folder, and I have all these different regions of the world. And this here is Hawaii, and I will take just the last version, which is the sorted MSH. All right. In order to visualize it, it's not a time series, okay, so just click on this other data drop list and choose for the bathymetry from Gmesh, and here you have it. So the default plot type is contour fill, which can be rather slow, so you can switch to TV, which just essentially plots a matrix image. And so that's the bathymetry from the grid. If you want to see the triangles, just you have to overlay the triangles here, so just click on the triangles. You want to click on refresh here, and what I will do now is to open the mesh editor tool, which is opened by clicking on the mesh here, and here we have the mesh editor. So this big matrix on the top here is just a list of the nodes and their position and everything, so you could actually edit node position directly in there, but it's a bit tedious. What I will do now is actually to compute the time steps that WAVEWATCH will use for this mesh. And so we'll do that by clicking here on the update model timesteps. Otherwise you could read these timesteps from a file generated by either Polymesh or WAVEWATCH. Okay, and since I'm doing it, I have my small IDL window open here, and okay, now it gives this list of smallest timesteps, so it's sorted by the timestep, and here are the list of nodes, and the next list is the list of timesteps. So what this means that the first node here, number 13950, requires a timestep of 13 seconds. Of course, that's a function of the wave period, and it will also be a function of the water level. So there's an offset in the water level which is used here, which is set to 4 meters, and you can change it here. And there's a default wave period that is used, which is 26 some seconds. That corresponds to my usual first frequency in my WAVEWATCH grids. Okay, so now we have computed these nodes, and if we just click on refresh, then we'll see all these symbols with different colors. And what are these? Well, these are the first 200 nodes in this list of the nodes that are requesting the smallest time steps. And they go from blue to red, and so the really bad guys are the red ones, which are really causing the small time step. And the last one, to highlight it, I chose to make it with a different color, and this is why I have this palette here, which is this blue color here, which is the last one after the red. And so if we just zoom on this small triangle, so we'll just click on zoom and zoom again. Okay, so the blue guy is, and you can also scroll with the arrow, and I don't know why colors have changed. It's very strange. Palette. This is my way of reading the palette. Okay, I want to have the white background again. Okay. somehow I have a black background now, whatever. So if I choose a node here, this is number 13.90950, and you have the number, oops, oh yeah, this is not, and the blue one next to it here, yeah, this is number 13.950, and this is the triangle which is causing this time step to be so small. Okay, so what can we do about it? Well, we could try to move around the nodes around it. For example, if you go back to the mesh editor and I'll click on this move GP, and I just take one node next to it and just move it around, like this one. Okay, let's put it here, and you'll see that the color has changed now. Okay, and if you look in your window here, you will see that no, this has not been updated. It should have been. Okay, so we could just recompute everything, and you will see that now node number 13.950 will not be on the top of the list anymore. Okay, and now the next one on top of the list is number 8080, and what we have done in the meantime is we've gone from time step of 13 seconds to 14.7, so we've gained 1 second, like it's almost 5-6% of the CPU time that will be reduced by just moving one node. So you want to be careful with these funny nodes that are problematic. So you can either move the nodes by hand, or you can look at why some nodes are bad in general. And this one is actually bad because it has 4 neighbors, and this is a configuration that favors these small time steps. So one thing that can be done actually to remove this node, and that can be done by, for example, okay, in the mesh editor here, first you have to pick this guy, and once we've picked it, we can remove the selected node which has 4 neighbors. Okay, this is this, all right, and now just refresh, and the node is gone, and you can update again time steps, and you will see that the red symbol is gone now. Okay, let's zoom out, and okay, the next bad guy, the blue one here, is this guy here. So what's wrong with him? What's wrong with this guy? Hey, what's happening again? Well, that's another node with 4 neighbors. So you know what we're going to do? We're just going to kill all the bad guys that have 4 neighbors. Okay, we'll do that here. Remove all nodes with 4 neighbors. Here we go. And it's going here, it's removing all these nodes and reshuffling the triangles. It's going to take a bit of time. Right, now it's done, and we just do a refresh here, and we can also update model time steps and see what happens. Okay, so now the time step is up to 16.9 seconds. Much better, right? And if we just refresh and zoom out, well, now the blue guy is here, and the blue guy, well, yeah, so that's the case. If you want to increase that time step, you have to move this one by hand, and we can do it the way we did it before. So one interesting thing is that if you move this node, it will actually not change the time step. It will change the time steps of the nodes around it. So if you want to increase the time step at that node, you have to move the other nodes, not itself. So for example, let's move this guy here along the depth contour, and now, oops, we've gone from blue to orange, and you have this information here. The time steps was blah 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 blah, and then 16.9, and now it's increased all the way up to 22.5. So this is a very efficient way of cleaning things up, and there are several other options. You can remove nodes that have 3 neighbors or 2 neighbors or other things like this. And once you're happy with your mesh, you can just save it. Save the mesh, and we're going to call it sorted clean 1. Okay, and now I can use that mesh inside of WaveWatch and have a faster runtime. That's it. Enjoy.